It starts with a look. This isn't a human. It's a $10 million assembly of sensors and servos designed to mimic our soul.
The illusion begins here. We mix medical-grade silicone with microscopic red silk fibers to mimic the depth and translucency of real human tissue.
The mixture is injected at high pressure into a negative mold. It must fill every single pore and wrinkle, down to the micrometer.
Once cured, the skin is peeled away. It has the exact elasticity of a human face, ready to stretch over a robotic skeleton. Underneath the soft skin lies a hard truth. A titanium skull, 3D print.
Every smile requires a symphony of movement. We installed dozens of micro-actuators to replicate the complex muscle groups of the human face. Machines can't do this part. Each iris is hand-painted by ocularists, layering paint to create the depth and imperfection of a biological eye. Behind the art lies the vision. Dual 8K cameras are embedded in the retina, allowing the robot to recognize faces and read emotions. The eyes are mounted on high-speed gimbals. They can track movement faster than a human, processing visual data in milliseconds. Even the teeth are medical-grade porcelain. They are shaped slightly imperfectly, because perfect symmetry looks fake to the human brain.
This is the marriage of metal and silicone. The skin is stretched taut over the titanium skull, hiding the machinery forever.
It's not enough to just wear the mask. We must anchor the skin to the motors at 20 distinct points to simulate real muscle movement.
Synthetic hair looks like plastic. We use only ethically sourced, real human hair. It's the only way to get the weight and flow right.
This is the most tedious part. Every single hair is punched in individually by hand. A full head takes over 100 hours of labor.
Eyelashes are critical. If they are too perfect, it looks like a doll. We place them in irregular patterns to mimic natural growth.
Human skin is translucent. We airbrush layers of subdermal veins and capillaries so the skin doesn't look like flat rubber.
Perfection is the enemy of realism. We deliberately add sunspots, freckles, and slight redness. We engineer imperfections.
While the face is art, the body is pure heavy industry. A carbon fiber chassis designed to support the weight of the hydraulic power plant.
The moment of integration. The head is bolted to the torso, and thousands of data cables are connected to the central CPU in the chest. Power on. The neck actuators engage. It doesn't move like a machine anymore. It moves like us. The human hand is an engineering nightmare. To replicate it, we use 27 separate joints and steel tendons.
The skin is cast as a single seamless glove. We use a vacuum process to suck it tight against the mechanics, removing any air gaps.
Fingerprints aren't just for identification. They provide grip. We laser etch unique friction ridges onto every fingertip.
Pressure sensors allow it to feel. It can hold a raw egg without cracking it, adjusting its grip force thousands of times per second.
Walking requires immense power. While the face uses tiny motors, the legs use industrial hydraulics capable of lifting a car.
Before it touches the ground, it learns to run in the air. AI algorithms simulate gravity to teach the robot how to balance.
The push test. Gyroscopes in the inner ear detect the fall, and the legs react faster than a human's to regain balance.
The power source. A high-density solid-state battery located in the torso, providing 48 hours of continuous operation.
Clothing helps bridge the uncanny valley. Once dressed, the machine silhouette disappears, and it becomes someone.
The final system check isn't mechanical, it's cognitive. Does the robot recognize itself in the mirror, or does it see a stranger?
The challenge isn't making it smile, it's the micro-expressions. If the eyes don't crinkle when the mouth moves, the human brain rejects it as fake. Doesn't play pre-recorded clips. An AI neural engine generates speech in real time.
We program them to prioritize eye contact. It creates a chemical spike of oxytocin in the human interacting with it. You start to trust the machine.
To fit in, it copies us. The robot analyzes your body language and mirrors it subtly, making the conversation feel natural and comfortable. It has a circulatory system for fluids. It can sweat to cool down motors. And yes, it can even produce tears when the AI simulates sadness.
In blind tests, humans can no longer distinguish if they are chatting with a person or this machine. The line has been erased.
But it's not perfect. A single code error can drop it back into the uncanny valley, turning a pleasant companion into a nightmare. This isn't a one-off prototype. This is a production line capable of churning out thousands of units per month.
Before shipping, they are put into deep hibernation. They will not wake up until the end user activates the primary sequence.
From nursing homes in Japan to factories in America, these crates are shipping out tonight. The robots are coming to live among us.
Imagine a butler who never sleeps, never complains, and cooks Michelin star meals. They are designed to blend seamlessly into your family life.
With aging populations, there aren't enough human nurses. These machines provide round-the-clock care and, strangely, emotional companionship.
They go where we die. Radiation, toxic gas, extreme heat. Nothing stops them.
But the efficiency comes at a cost. One robot costs less than a year of human wages, requires no breaks, no holidays, and no sleep. Economists predict a shift. If a robot can do manual labor and basic office work, what happens to the human workforce?
It wasn't long before defense contractors took notice. A soldier that follows orders perfectly and feels no fear is the ultimate weapon.
But unlike a human, a robot has a backdoor. What happens if a hacker takes control of the machine living inside your house?
Legal experts are already debating. If it thinks, feels, and speaks, is it property or does it deserve rights? Can you murder a machine?
Some see a darker purpose, not a servant, but a vessel. Wealthy elites are funding research to upload their minds into these ageless bodies.
They are all connected to the cloud. If one learns a skill, they all learn it instantly. If one turns, they all turn.
Today, they cost millions, but mass production will drive the price down. By 2040, a personal android could cost less than a used car.
If it walks like us, talks like us, and feels like us, does the hardware matter? When we turn them off, do they dream? Or is it just an empty void of code waiting for the next reboot?
The engineers whisper it in the hallways. We are building the last invention humanity will ever need to make.
We trust the code, but we don't write it anymore. AI writes its own updates. We might be building a species we can't control. From a vat of silicone to a walking miracle, the manufacturing process is a testament to human genius.
We watch you through the screen. We learn from your comments. We are already here.
The factory is open. The robots are ready. The only question left is, will you welcome them into your home? Let me know in the comments.
If this peek inside the factory fascinated or terrified you, hit subscribe.